Thanks, Billy. We're going to talk about science. So you've seen this cartoon before, or maybe a form of it. Particularly, you might remember it from when I was last year when we talked about epistemology, and even before that when I was trying to recruit some people to study philosophy. So we've got here, the basic cartoon is the one in the frame, all right, and then you have the philosophers come along and they're a little bit antagonistic, saying you've all got philosophical assumptions. So mathematics, right? So the abstraction of numbers and combining things, and we've got these mathematical laws and seeing how all those things work together. And then physics, if you've studied physics, you understand that you've just got simple formula that describe the world, all right? You can throw a pen, predict where it's going to land, and you're just crunching numbers in the formula. We have a simple understanding of it. All right, and the physicists, they generate the atomic model. All right, so that's generated by Niels Bohr, the atomic model describing the atom, and the chemists are using that periodic table, aren't they, by Mendeleev, and they're using it to describe how different chemicals interact with one another. And then the biologists, they're assuming this understanding of chemistry, all right, because what are living things but complex chemical organisms mashed together and operating. And then psychologists is an application of living things, right? And then we've got sociologists. So. But all of those bear philosophical assumptions. In fact, I would argue that all of these things, if metaphysics, right, is a description about the nature of reality, then all of these things are fields of metaphysics, aren't they? They're all parts of metaphysics, and they all have epistemological assumptions. That is, assumptions about knowledge and assumptions about how we can gather knowledge. So I thought we would start with, we're just all going to list one science, because there's lots of fields of science, and some of them are up there, but I want to try and just generate a bit of a list here, and I'm going to point out a little bit of a word pattern as well. So gents, can you name a science for me?
Sports science.
Sports science. I'm going to skip that way so you can't see. Sports science, very good. Yep, so that's one of the subjects they're doing here at the moment. Sports science, is anyone in that? All right, so they do stuff like, it's a bit like PE, but I think more scientific based, isn't it? Yeah. All right, very good. Thanks, gents. Michael?
Marine biology.
Marine biology, very good. So biology, but this is a localized field of biology in the sky, right? In the ocean, okay. In the sea, in the water. Matt?
Food science.
Food science, yep. So like nutrition and stuff, very good. Billy?
Geology.
Geology, very good. What's geology?
Rocks and sediments. And
Perfect. Study of rocks, study of the earth's core. Alex?
Astrology.
No. Astronomy, yes.
Yeah, that's
Astronomy. Are you trying to stir me up? Astronomy, very good.
Biochem.
Biochem. So what's that? Biology and chemistry combined. And Emma?
Zoology.
Zoology. So what would that be? Study of
Animals.
study of animals that were in the zoo.
Physics.
Physics, very good. So PH. So I'm not certain of this, but just thinking of that, perhaps zoology is concerned with animals, biology concerned with living things. Zoology is a field that looks at animals per se. Physics, so like a couple others we've got biology. I just want to add a few. We've got geology, anthropology, so that's the study of the emergence of man, okay, so out of Africa theory, and we're the sort of apes in Africa, and they're our cousins, and once we got down from the trees and started walking around the savannas, we spread out all over the earth. So anthropology, that's quite a fascinating history. And one more, psychology. I'll write it up here, I'll give them their due. All right, so I just want to point out here something about words. Firstly, ology. Where, does anyone know what that word, the root of that word is, ology? It's a Greek word, and it's logos. And what that is it means sort of reason, sort of word, justification. those are sort of words to describe it, all right? And so within this is like, what are the reasons for living things? What are the reasons for the way rocks are the way they are? All right. So that's the root of that. Okay. The next thing I wanted to talk about then is in science. Okay, we would have a good idea of this. Well, even before that, what is science? What is it? Without looking up the slides up here, I'm going to jump back a little bit. What is it? And I've got two answers, but I want to see what you guys think. If someone said to you, a preschooler, what is science? Like, or someone that might be able to understand it but doesn't know, what would you say?
Trying to figure out why and how things happen.
Excellent. All right. So it's about acquiring knowledge, isn't it? Just trying to figure out why and how things happen. Very good. So that would be my first one. Is it's a method of acquiring knowledge. So the first one is that it's a method, and linked to that is the second one. I would say is that it's a collective. Reluctant to use the word knowledge. It's a collective consensus of the things that we've discovered about the world. Okay, so there's the body of science. That's the word I'm looking for. There's the body of science, which we consider things like scientific facts. Okay, descriptions of the world. All right, so we can say if something's science, then it belongs in that body of science, right? You look at the textbooks, you look at Wikipedia. There's this page of facts. Okay, and then we've got the method. So there's a method of acquiring things, and then there's the body, the knowledge and the information that we have from it. Okay, so that's good. So then let's talk about, well, what are some of the axioms that we hold when we're performing science? This is where the philosophy comes in. This is where the epistemology is. These are the fundamental assumptions that we have for us to perform science. All right, so let's see what we can come up with. If you're going to perform a scientific experiment, what are things you need to assume about the world?
The world is real.
Perfect, that the world exists, isn't it? The world exists beyond. Do you need to assume that it exists beyond your sense of it? Because, so like Flynn, your argument for idealism, if the world is just an idea in your mind, can you still perform science?
It's like one of those complex ideas that just layers and layers.
Layers and layers, layers. I think the answer is yes, because if the world in your mind is sort of reasonable, you can perform science. Because I think the answer is yes. So we don't have to say like it exists beyond your sense of it and your observation of it. We just need to posit that it exists in some manner, and we won't the more details we add here, the less people we can fit around the table for the discussion. So we'll try and keep them vague, just to get people involved in the discussion. So good one, the world exists. What else are we assuming?
We see the world as it is.
Yeah. Or that our senses inform us about the world, yeah. So not necessarily, I don't think it would have to be as it is, but definitely that they inform us to some degree. Our senses inform us. Very good. Yep. Our senses inform us about the world. And then to the degree to which they inform us, whether we see it as it is or as it approximately is. All right, they're good. Any others? Gents?
Also, like the world is consistent.
Consistent, perfect. Yep, consistent, regular, or like I would use the word ordered, because I think that's what it means for something to be consistent. It has some order to it. Yep.
Things happen like for a reason.
Yep. So like a principle of causality or something like that. Yep. So I'll write PC, principle of causality. Like all events that occur have some cause beyond them. That's generally what science is talking about, isn't it? We're trying to find what are the causes that have allowed this thing to happen. We speak in terms of causes, and then probably as a superset to that. So you think of a subset, a superset, the opposite. What principle of causality is encompassed in is PSR. All right, principle of sufficient reason. So the difference between them, this is about causes, and it's specifically about efficient causes, what brings something into existence, whereas PSR is about reasons. And reasons aren't always causes, but all causes are reasons. Okay? All right, so let's skip on. That's a pretty good discussion about science, about the axioms we've got, and then what it is, and here's some science that's good. Maybe I'll just say one more thing about, that might come up. Okay, so we've said, here's these three ways of thinking of science, right? And so we have these early understandings of it, and you've got people like Epicurus and some of the Stoics who are performing this empirical method, right, where they are making observations. William of Ockham, okay, where we get Ockham's razor from, who's a monk, by the way. Roger Bacon, Galileo, these are sort of where the empirical method emerges out, and not that they're all existing at the same time, right? Epicurus 2,700 years ago, Galileo 500 years ago. All right, so there's a big gap there where the empirical method is developing. And they're saying, what? It's about observation. Okay, drop the pen, falls to the ground, drop the pen, falls to the ground. It's observation, and so it's based on inductive reasoning. Okay, we're going to perform observations, and we're going to use specific instances to make general rules, general principles about the world. All right, Karl Popper, he's a logician in the 20th century, and he says, he adds to this, he says, yes, it's based on observation, but science is fundamentally about falsification. Is that the word I've used? Yes, falsification. That for something to be classified as science, you have to be able to falsify it. All right, you have to be able to prove that it's wrong, and that's how science works. Is we develop a theory that fits all of the data points, and then we test it. We try and find evidence that disconfirms it. All right, because if we find something that disconfirms it, it means our theory is wrong. And we can go back to the drawing board and come up with a new theory that fits all the data points together. So he says a core element of science is that it has to be falsifiable. And so then when you look at some of the metaphysical claims, lots of them aren't necessarily falsifiable. When we look at limitations of science in a moment, we'll have one of them is it's focused on the material world, right? And so if we're thinking of metaphysics, that's generally engaged with things that are beyond the physical. They're beyond the realm and the scope of this scientific method because they're not falsifiable in the scientific sense of the word. We can't perform an experiment that's going to prove whether or not they exist or don't exist. And this word paradigm shifts, okay, that's developed by a philosopher called Thomas Kuhn. So he's an American philosopher of science. And so paradigm, does anyone know what that word means?
Isn't it just like how you see things?
Perfect. Yep, it's a picture model of the world, and so a paradigm shift is a shift in your perspective of the world. And Kuhn says we shouldn't think of science as this sort of linear thing where we accumulate and it just gets, our body of knowledge just gets more and more and more. And he says that science happens in revolutions, in these dramatic paradigm shifts, because we have a model, and if there's something wrong with the model, it requires something needs to replace it. All right, and he goes through and offers heaps of examples. One of them might be the Copernican revolution, right? All right, so prior to Copernicus, we were the center of the solar system, and all of the stars have revolved around us, right? This planet, this is the home. And Copernicus says, well, maybe not, all right? And he performs his study, he's looking at the sky with telescopes, and he comes up and says, our sun is the center, and all of the planets revolve around the sun. And that's a dramatic change in thinking. Another one is Newton postulated that planets move in circular orbits. All right, and so Newton's theories don't work in terms of all planets orbiting a star, because planets actually move in elliptical orbits, so they're like elongated circles. And so that being another change. Another one is the age of the Earth. It's really interesting to look at how the history of how old is this planet that we're sitting on has changed. You know, so if you were to ask William of Ockham, all right, 1,000 years ago, he would have said 7,000 years, all right, 6,000 years, maybe. That would have been a biblical explanation, right? And then if you go back, you look at how it's changed. So different philosophers, different mathematicians, scientists with their models. So in like 1800, you have one fella, like Kelvin Thompson or something. He says 75,000 years. That's how old it is. And he did that by, he made an experiment where he created a model Earth, all right, and you know, he had this sort of red hot iron in the middle and this crust on the outside, and he was trying to work out how long would it take for it to become a state similar to ours, similar to the state that we have. He said 75,000 years, and then it's interesting seeing the revisions, 20 million years, 180 million years, and now does anyone know what the claim is for the age of the Earth?
4.5 billion.
4.5 billion, yep. 4.5 billion. All right, very good. So let's talk about this, if we think of methods of knowledge, right? Empiricism, rationalism. I'm going to offer one called Scientism, which would be a subset of empiricism, okay? So it belongs in the field of empiricism. And it says, not just through the senses, but the only way we acquire truth is through the scientific method. Okay, so that's the claim of Scientism. And they say, look at the unprecedented power that we've come to because of these scientific revolutions. Look at all of this technological success we've got. We have put people on the moon, apparently. We've got like spacecraft that are beyond our solar system, that have travelled further than our solar system. We've got photos of Pluto from those spacecraft flying past it. And you think about like that all of us have a supercomputer in your pocket right now. Right, where you can access the world. Like it's crazy what the amount of success that science has brought to our lives. Okay, so from that, there's a lot of reason to believe this is a good way of acquiring knowledge, and so you might be led to make an argument like this. Flynn, can you read it?
The predictive power and technological applications of science are unparalleled by those of any other purported source of knowledge. Therefore, what science reveals to us is probably all that is real.
All right. So, like, it seems pretty convincing on the face of it, I think. You're just like, yeah, like, look at all this success around us, and maybe people that haven't studied philosophy would be pretty willing to say, yep, agree, science is a good way for us to acquire knowledge. Anything beyond that isn't really worth studying. All right, but we sort of know a bit better than that, don't we? Because let's look at an argument by analogy. I think this is a pretty clever argument by analogy. So Nat, can you read that one?
Metal detectors have had greater success at finding metallic objects than any other method has. Therefore, metal detectors reveal to us all that is probably real.
So it's an argument by analogy. All right, so if we think of the first one, look at this predictive power and success. Look at this technological revolution. It's amazing. That's what science has given to us. Therefore, it's better than any other method, right? We've arrived at all these things, therefore it's probably all that's real. Right? Material world is probably all that's real. And then this one's saying, well, metal detectors really good at finding metallic objects on the beach. So therefore, metal detectors probably only reveal what is real. Fair, unfair, any comments?
It's a little bit different because science is a wider scope than just metallic objects.
Yeah, I think the conclusion for the second argument should be all metal that is real.
Yeah, so I think the analogy though is, here it's talking about specifically, what is the scope of science? Material things, okay? And here it's talking specifically about metallic things. So their conclusion here is that only material things exist. And the conclusion here is that only metal things exist, which is an absurd conclusion, right? Based off the first premise. So the question is it absurd to conclude that only material things exist based off the first premise? All right. So let's look at some limitations then of the scientific method. So it's beautiful, it's given us so many things, but I want to talk about some limitations for you. The first is that science is reductionistic. So that is, it reduces complex phenomena to a more simple explanation. So I'm going to offer a thought experiment. The thought experiment is called Mary's Room, and it's a famous philosophical thought experiment, although I'm going to describe it a bit differently. What I have on the side here is a Vietnamese delicacy, and it is called chair. Chair. All right. Has anyone had chair before? I have, and I'm going to describe it to you. All right. It's composed of carbon, oxygen, nitrogen, and other residual elements. Okay. Do you know what it tastes like? Okay, so that's the exact point, all right? Even if you have a complete scientific understanding of all of the elements that chair is made of, you don't know what it tastes like. Like, it's missing that qualitative aspect of it. The same with colour, all right? You can describe the colour of a beautiful sunset or whatever. What does science seek to do? It seeks to put that as a number, all right? The red wavelength of red light film,
So
700 nanometers. All right. So that's it. It's reducing this whole qualitative experience of the world to numbers. All right, to elements. All right? Removes our fundamental experience of it. The second is that science is a model. So what I mean by that is, when we think of truth, right, we're generally trying to come up with a correspondence theory of truth. All right, so we're generally looking at what is it that corresponds to reality. So I'm going to provide a maths description, right? Here are two data points, and science is trying to fit a model to it. You've made some observations, hopefully you've got more than two, and you're trying to fit a model to it. Now the problem is, there are an infinite number of models that can pass through these two data points. Okay, we could have a quadratic like this, we could have a quadratic like that, we could have a cubic function like this. There are an infinite number of ways that you can describe the relationship between these two data points. Okay? Similarly with science, if you think of something like the periodic table, right? Periodic table does not describe the things that exist ontologically. All right? Carbon, oxygen, nitrogen, those things don't exist if you were to zoom in and see them, they don't exist as such. All right? Rather, the way things interact with one another suggests that they exist in this way. All right? Or this way works to describe how these things interact with each other. All right? So carbon, oxygen, nitrogen, these elements I've described here, they don't actually exist. Rather, it's just a useful way to describe the complex interaction that's going on. And there are an infinite number of other models that could have been used. The periodic table and the way that it's been assembled is just one of those. So, yeah, that's a philosophical claim. The third point I've got explains how and not why. So the one I like to describe here is a match, right? If I say, my child comes up to me, Dad, why when I strike the match does it produce flame? Why does it produce a flame? And I could get really technical. I'd say, oh yeah, excellent. So what's going on? You've got the matchstick, here's the match head, and in here there's sulfur. All right, sulfur. And when sulfur is exposed to friction, all right? When sulfur is exposed to friction and oxygen, and sulfur, if you have those things together, you're going to get fire. All right, so I can explain that. Philosophers will say, you have not explained anything. All right? Here we've got this process, right? We've got match hits box, all right, fire. Down here, I've got oxygen hits sulfur, hits friction. We've got fire. I haven't explained anything at all. All I've done is said, this thing's made of these smaller parts, and this thing's made of these smaller parts, and these smaller parts together make fire. The question is, why is there fire? There's no explanation of why whatsoever. All we've done is explain it in terms of smaller parts. We've just restated the problem. All right? And then the last one is that as it relies on inductive reasoning, nothing is ever proven, right? It's always open to falsification. The more evidence we have, the more probable a conclusion is, but there's always the opportunity of falsification. Okay, lastly, what is the demarcation point of science? So if you think, what are the core things you need for a scientific experiment? You want to control the variables. What does that mean if you're trying to control the variables? What does that mean?
Keep things consistent.
Excellent, you're trying to keep things consistent. So like if you're doing a simple experiment, like dropping the pen and timing how long it takes to fall to the ground, all right, you won't perform it in here one day and then outside when there's a tornado another day, all right? that's going to be inconsistent because the tornado might affect how fast it takes the thing to fall to the ground. And so there's all of these variables that we're trying to keep consistent, right? You know, the temperature, everything that can affect a scientific experiment. So we've got to control the variables. And we're trying to make an observation. Yet that's interesting because we wrote up here all of these sciences where we're not really observing things occurring. Anthropology, geology, biology with regarding evolution. Okay, we can look at like bacteria evolving, and there's evidence there, but in terms of the historical evolutionary record, that's not something that we observe. We can find fossils, and we can make observations of the fossils, but we're not observing, you know, man emerging out of Africa. Rather, we're looking back at evidence. So how can we classify? I'm interested to hear what you think of this. How can we classify these things as science if they don't perform hard experiments like physics and chemistry? Physics and chemistry is like, here's a theory, I can test it right now. Biology says, here's a theory, there's some bones that suggest it's true. Same with anthropology, same with geology, the way the rocks are. Psychology, like the reason psychology gets a hard rap is because of how incredibly complex human beings are. Like it's aiming to do experiments on human beings, right? But human beings are incredibly complex. So you think of the amount that goes into us making a decision, and how do you control a psychological experiment? Well, let's say you're doing something like, you know, you're going to track kids from the age of 5 to the end of high school. So when they start school to the end of high school, on how eating breakfast affects their results. Okay, like seriously, that might be something that you're interested in looking at. All right, does eating breakfast help you get a better result? And like, what are all the things that are incredibly varied in it? People have different IQ, people have different socioeconomic backgrounds, people are going to different schools. So there's all these variables that are going to affect the result that you need to consider in the experiment. That's why it can get a bit of a bad rap. So when I say demarcation point of science, what is science? We've clearly got these hard sciences, okay? So physics and chemistry, where we can perform experiments around them, all right? And even within physics, you can get what's called theoretical physicists who just perform basic mathematics. You know, they're not performing any experiments because they're trying to develop theories around unifying the different models of the world. So physics, chemistry, hard sciences, we can observe it. But then beyond that, you know, we can observe how different life forms reproduce and so forth. But yeah, some of these things, how do we consider things like evolution, like history of the earth? How do we consider geology a part of science if we're not making observations of it? So this is the question of the demarcation point. So it's when does something transition from being science to non-science? Because is this process that we're performing here in philosophy, is that a type of science? We're looking at arguments, all right? We're collecting evidence. So I'll read you a quote about that, and that's it. So attempts to define science by references to a distinctive method have proven problematic because different branches in different types of science use different methods. Some perform lab experiments under controlled and replicable conditions, while others attempt to reconstruct or explain singular events in the past, often based off limited studies or evidence or clues. Some disciplines generate mathematical descriptions without positing mechanisms to explain them. Others look for mechanisms to explain irregularities in reality. Some make predictions to test theories, while others test competing theories by comparing their explanatory power. Some disciplines use both, while some disciplines have conjectures that may not be testable at all. Okay, so for this reason, philosophers of science. So these are people who have studied philosophy, and they're attempting to narrow the scope of science. All right, someone who's majored in what is science as a philosophical enterprise. Philosophers of science. The scholars who study the nature and definition of science now almost universally reject the use of demarcation arguments to decide the validity of theories. All right? They generally agree that it is more important to assess whether a theory is true or whether evidence supports it than whether it should be classified as science or not. All right, so this is philosophers of science, almost universal agreement that these demarcation arguments, like separating hard science from soft science, from geology and so forth, no point having that argument. Rather, we've got a theory of the world. What's the evidence in support of it? All right, thanks, Billy. You stop there. So, does anyone have any comments on